Hello, my name is Kai and I will guide you in today's lesson. In this lesson, we will explore the activities for the accelerometer sensor. The Grove 3-axis digital accelerometer module, also known as a triaxial accelerometer, measures movement in the X, Y, and the Z axis. The accelerometer module has a digital output and makes use of the I2C Communication protocol, which is supported by the Arduino Uno. The module sends out the data through the pins VCC, GND, SDA or the data line that is responsible for the transfer of data, and the SCL or the clock line that is responsible for synchronization. Note that these modules are already internally connected to the Grove base shield. You do not need to use the Grove connectors when you have not broken the modules out of the board. I am only presenting to you how to connect the modules on the shield, assuming that the modules have been broken out from the Arduino Sensor Kit Base. Connect your acceleration module to the I2C pin. Once it's all connected, attach the shield to your Arduino Uno and connect it to your computer. In order to use the accelerometer sensor, we need to include the Arduino Sensor Kit library. Afterwards, we have to define the X, Y, and Z variables as a float. In the setup function, we input accelerometer.begin in order to turn on our sensor. Afterwards, let's add a serial.begin 9600 baud rate in order to read the serial monitor. Now for the loop function, in order to read the X, Y, and Z values of the sensor, we need to use the accelerometer.readX, accelerometer.readY, and accelerometer.readZ functions on each of our X, Y, and Z variables. Next, we're going to print all these values in the serial monitor. When we're done, all you have to do is add a 500 millisecond delay on the loop. Once done, click on upload and it will automatically compile and upload to your board. Now, open your serial monitor and try to tilt your accelerometer sensor and see how the values of X, Y, and Z vary. For this next variation, we're going to add a buzzer to our project. Connect the buzzer to D5. For this next variation, we have to define the buzzer as pin 5. Then on the setup function, set the buzzer as an output. Now in the loop function, I'm going to add an if statement that indicates that if the y value is less than or equal to negative 0.6, or if the y value is greater than or equal to 0.6, or the z value is less than or equal to 0.70, then the buzzer will ring. Inside this if statement, add a tone function that indicates the buzzer and the frequency it will run. In my case, it's 1000 Hz. Next, add an else statement and just add no tone function with the buzzer pin. Once done, click on upload and it will automatically compile and upload to your board. Opening up your serial monitor, you will be able to identify and monitor the values of the accelerometer. Once it reaches the values as indicated in our if statement, you will be able to hear the buzzer buzz. You can pick up your acceleration sensor and try tilting it until the buzzer makes a sound. For this final variation, all we have to do is connect the LED to D6. We're going to add an LED pin. In order to do this, we have to define the LED pin as 6. Then, on the setup function, we have to indicate this LED pin as an output. In the loop function, we copy the if-else statement and paste it right above. Afterwards, we delete the tone and the no tone functions and replace them with digital write, LED high in the if statement, and LED low in the else statement. We simply have to change the if conditions into something lower than the ones below. In this case, y-val is less than or equal to negative 0.6, or y-val is greater than or equal to 0.6, or if z-val is less than or equal to 0.7. Once done, click on upload and it will automatically compile and upload to your board. Once your code is done uploading, you can now open your serial monitor and you can pick up your acceleration sensor and try tilting it a bit and watch as the LED lights up. Tilt it a bit more and the buzzer also makes a sound.
Now that is it for this lesson. To learn more about the other modules, simply head on to the next video.